Now for this part of the question, we've got to find the domain of the inverse function of f. And in the last part we found out what the inverse function was, but don't really have to use it. What we should know is that the domain of the inverse function is exactly the same as the range of the original function, f of x in this case. And when it comes to working out domains and ranges, I'd always encourage you to draw the graph. So what I'm going to do is think about what this graph of f of x looks like. So if we were to draw our axes, say, okay, let's have our y-axis here and our x-axis like so, then we're looking at the graph of 4 minus the natural log of x plus 2 for x greater than or equal to minus 1. So if we were to step back at minus 1, if we were to put minus 1 into here, we've got the natural log of minus 1 plus 2, the natural log of 1 then, which you should know is 0. So this has a value of 4 when x is minus 1. So I'll put 4 there. Okay, that's at 4. Now, as I put, let's say when we put x is 0 in here, then you're going to have the natural log of 2. And if you were to do 4 minus the natural log of 2, you'd find you get a positive value less than 4. It's going to be some value down here, say. Okay? But then as we let x get bigger and bigger, what happens? This quantity gets bigger. And soon or later it exceeds the 4. And so what happens is that this graph looks something like this. It comes down like so, crosses the x-axis, gets bigger and bigger, very slowly though, but it goes out like this if I think about this graph. So when it comes to looking at what the range of f of x is for x greater than or equal to minus 1, you can see, I hope, that it goes from this maximum value here at 4, and then it goes from here all the way down out to minus infinity. Obviously you can't equal minus infinity, but it's any value less than or equal to 4. So that becomes the domain of the inverse function. So the domain of the inverse function, f to the minus 1 of x, then is such that x is any value less than or equal to 4. And this idea, by the way, is based on the concept that when you have any function, let's just show you here, if you've got any function y equals, say, f of x, and you've got some graph maybe looking like this, say, this is y equals f of x, then the inverse function is a mirror image of this graph in the line y equals x, and y equals x is a line like that. Let's just put that as y equals x. So if I was to mirror this in this line here, we'd get a graph looking something like this, I would imagine. Okay? Now the point about the domain of one function being the range of another is because if we look at, say, the domain of the inverse function, and I better write that in, that this green one is y equals f to the minus 1 of x. This is the inverse function. Notice how its domain would go from this value here, okay, all the way to this value here. So this would be the domain of the inverse function. But if you reflect this in the line y equals x, can you see that this goes from here, this point here maps across to here, this point maps across on the y-axis to a point over there, that what you've got now is that the domain of the inverse function is the range of the original function y equals f of x. You can see that it goes from this lowest point to this highest point here, and that's why we get this how we get this concept. Okay, So I hope that's given you some idea then how we go about that question.